Hey everyone, welcome back to the channel. Today we are diving into another exciting problem solving section. I'll break it down step by step so you can master it with ease. Let's get started. Today's question is medium question on lead code. The title is Maximum Candies Allocated to K Children. Okay, let's read the problem statement. You're given a zero indexed integer array candies. Okay. Each element in the array denotes a pile of candies of size candies of five. Okay. There were five candies of 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 one type, and there were eight candies of another type, and so on. Okay. You can divide each pile into another subpile, so but you cannot merge them into piles together. Okay. This line says that I can divide the five into some three comma two, like three piles, like group of three chocolates and another group of two chocolates. Okay, but I cannot merge two piles together. If there was some two piles, we cannot merge them, like I just said. You're also given an integer k. You should allocate piles of candies to k children. Okay, such that each child gets same number of candies. Uh, Here the problem is asking us to we have to allocate uh, some piles of chocolate to k children equally. So uh, each child each child can be allocated candies from only one pile of candies. Some piles of candies may go unused. So if there are eight chocolates of one pile, we can divide like some five chocolates to one child, and the remaining three can be unused. That is what it means. Okay. So based on this condition, can be written the maximum number of candles each child can get. Okay. Let's go to one example first. We have three piles here, and there were three children. What they are doing is we have five, eight, six. So we can divide it. The answer is five actually in this case. How we can think? Let's say if we pick one chocolate from each pile, so we can divide to three children. That is one case, but this is not the maximum. Maybe we can do two two chocolates from each pile, like two out of five, out of eight. So which can be possible, and three. Yes, three can also be possible. Four can also be possible for three children to distribute. Five is also possible. How? We can divide this eight into five comma three, and this six can be five comma one, right? So we have three piles of five candies, three times. Let's try to do six. We cannot have a six, right? So six cannot be a possible. From six till eight, it is not possible to distribute to k children. So, so the very main approach we can do is before that, let's try to see the constraints. The number of piles a group of chocolates is 10 power 5, and each chocolate, the pile size can be ranges from 1 to 10 power 7, and k can be 10 power 12, which is very large number. K is a long number, right? Basically, in Java, 10 power 10 above is we should use long data type. Uh, so we start from 1 and we can go till the maximum pile in the given candies and see if we can divide among k children. So that is the question. So if we do it, it will be n times and each time we have to process whether we can do it or not. That is on another, which is of n square time complexity. Or else, what we can do is, can we do it? Can we optimize the solution? Uh, like we assume one. What we are doing is we start from starting from one till max, right? In the given candies. And we are seeing whether this candy can be pile of candy can be distributed among k children. So that is one method. Some method check the above can be distributed among k children. So this is of big of n, and this to check this is of another big of n. So overall time complexity will be m square, which is nothing but n times n. Let's try to do the brute force and try to we can optimize it using binary search. How? Let's get first we'll try to do it in the linear way first. Uh, so we want a maximum candy pile. We so so we can define our own method, but I'm just using strings here of max. Basically, it returns an optional int. So we need to handle the null case with integer dot min value. So we start with I equal to 1. So let's call it maximum piles. Okay. Mm, This should be a list of string, sorry. Uh, can distribute and can distribute candies of pile or k. If so, let's say we cannot find. So this file will be our answer. Okay. Uh, let's try to implement this method. Okay. This case should be long because it is long here. Um, if this number of candies is greater than or equal to k, that means if we can divide it or more than k or equal, we can distribute, right? So number of candies is divided by, yeah. So this is the method. Let's try to run, but this will fail because this maximum pile can be like 10 power 7, and this method runs n times, which is size of these candies, which is 10 power 5, which is like 10 power 5 times 10 power 7. So it will for sure fail. Let's try to submit this one. So to check this, so we got a TLE. This is expected. So we can do better than this. Since the way we are evaluating our answers, we started from 1 and we are going till the maximum pair, right? So instead of that, can we check something like we check as some middle time and see if we can distribute. If we can distribute, we can discard the left part, right? Because we want to find the maximum candy. So there is a chance of finding on the right part. And if we don't find, let's say if mid cannot be distributed among k children, then so the right part cannot be distributed because it will for sure increase. So there is a chance of finding in the left part. So it is basically finding the upper bound uh, question. Like in the previous video, you can see, you can watch my previous video on binary search, mastering binary search on lower bound and upper bound. You can, we can apply the same principle here, like defining the boundaries. And there is an order, right? The pile gets increased in an increasing order. And so let's try to do in that way. Instead of going from 1 till the maximum pile, what we can do, same, we can use the same template as previous video. We can watch that video. Instead of this linear loop, what we can do is this is our set state, and we replace this linear loop with if can be distributed. Environment is equals to start as n minus time, and we replace this with. Now we find an answer here, so we can move to, since we want the maximum, and let's try to go on the right side because this is an increasing order. So our start will become mid plus 1, and if we don't find the answer, we for sure we'll have to discard the right part. So this is it. Let's try to submit now. Uh, our start should start from 1, sorry. Okay, got it. Now it got. Now let's try to submit this. Not a wrong answer. Let's try to decode. What we are doing is 1 less than. Okay, there is a chance of overflow here because we are doing 10 power 5 plus 10 power 7. So this can be an overflow issue. Let's try to submit it. Yeah, accept it. Let's try to analyze the time and space complexity. Uh, this method runs n time, where n is the size of Candies array. And here we are doing every time start plus n divided by 2. So we are halving the, yeah, we are doing by half each time. So it will run logarithmic time, and each time we are doing linear operation, so it will be n times big of n times log of n base 2, and space we are not using any, uh, so it will be big of 1. So this is the time and space complexity for this solution. And that's it for today. Hope you found this helpful. If you did, don't forget to like, share, and subscribe for more problem solving content. See you in the next one. Keep coding and keep improving. Bye.